Hey, what's up guys? Baby Bear 4812 coming at you one more time. And today we're doing an older problem. It's problem 155. It's called Min Stack. It's an object-oriented design problem. So I think it's a really cool one. And I think it's super deceptively marked as easy because it is not easy. This one definitely isn't easy at all. Okay, so if you're here because you got stuck with it and you're coming on over looking for help, nothing to be ashamed of. Okay. So what makes this problem interesting? Let me close this. What makes it interesting is as follows. So basically we need to implement the stack that does kind of the standard stuff. So push, pop, top, as in kind of getting the top element. And then the interesting one is retrieving the minimum element in constant time. In particular, this constant time piece is what makes this tricky and I think super not trivial. So we're told again, push kind of pushes an element onto the stack equivalent of append. Pop removes the top element. Pop gets the top element without removing it, and get min retrieves the minimum element in the stack. So I think it's pretty self-explanatory, and we're told in the constraints that the operations are always called on non-empty stacks, so we're not going to have to worry about error checking or anything like that. Basically, what's happening here in the input is they push a -2, a 0, a -3, and then they ask you to get the minimum value. In this case, that minimum value is this -3. It doesn't always have to be the one at the end, but it was here. We then pop that off. They check top. Top returns 0 because now what we have in our stack is the -2 and the 0. And then get min. Now we need to return -2, right? So we're not returning the 0. So there's a lot of different ways to think about approaching this problem, and really just to like wrap your head around where the difficulty really lays is in understanding the following. If I start adding items onto an array, I can simply track as I go while I'm adding them. I can continue to ask myself, is this number smaller than the last number was? So I can ask myself like this. If I do -2, and I can ask myself, is -2 either the first number or the smallest number? If it is, then maybe I can keep a variable min, and I'll set that equal to -2. We then add a 0, and we ask ourselves, okay, if we pop, or sorry, not if we pop, but if we add the 0, is it now our minimum element? Well, no, because it's greater than -2. Cool, we keep going. We add a -3. Is that minimum? Yes, it is. So we can keep track of this -3. Fine. We now get to this point, and we call a get min function, and the get min function returns the -3 or this one that we stored right here. And that's cool. But if we pop it off now, so I pop off the -3. Okay. -3 is no longer there. No, you know what? Here. -3 is no longer there, so I pop it off. It's gone out of the array. But the problem is now what's the smallest element? So we've gotten rid of the smallest one here, but it's like, okay, well, does that mean every time we pop it, we need to check if it's the minimum value? So that seems like a really weird approach. And you might ask yourself, well, what if every time this get min function is called, we actually walk through the entire array and check for the minimum item? And I would tell you that that's a fair solution. It does make the problem a bit trivial, and so it probably wouldn't really fly in an interview. And again, if you're asked to do it in constant time, then there's got to be a more clever way of keeping track and noticing, like, what is the minimum element at every step along the way. And that's really what the question boils down to. At every given step of the way, if I was to pop off an item, was my minimum value affected or not? If that was my minimum value, what was the previous minimum value to that? Or what was the one previous to that? And so on and so forth. And we need to find a way to do that, to keep track of every step along the way, what was the minimum value now, such that if we were to remove our current minimum value, we'd have historical reference to everything else. Or when I say to everything else, just to be clear, all the previous minimum values as we were growing and shrinking this array. And so that's kind of the key here, the point of confusion for many people in this problem. So if you haven't thought about it yet, pause the video, think about it for a couple minutes, see if you can come up with a really clever way to do it. Otherwise, this is what I'd suggest. And what I'll do is as follows. We're going to take advantage of a concept that can be known as invariance. Okay, so in math, for example, an invariant is a number simply that it won't change, kind of like a constant in the sense that if things happen in the future, what they were right now in this moment is they're locked and loaded. They're not going anywhere. Whatever happens from here on out in the position that I'm in isn't going to affect my value and my standing right now. So how do we do that? Well, let's think about this. What if I gave you a stack and I told you, or rather, let me put this even easier. Let's say I run with the numbers. If I had a -2, we got a -2 and they're fine. I can now add a 0. This -2 hasn't changed. It's still staying as it is, right? Even if I pop the 0 off, the -2 still remains. So one nice property about arrays is that as I'm adding on every one of these numbers one by one, ad infinitum, everything that happens before has not changed, okay? So lists or arrays have this really nice invariant property where all the preceding elements, the ones preceding the one you either pushed on or popped off, don't actually change. And we can use that to our advantage as follows. Every step along the way, instead of storing just the number, what I'm going to do is I'm going to store a list. You can do this with the tuple as well because it'll only have 2 elements in it. I'm going to store this value that we're adding in, such as a -2. And what I'm also going to store is what is the minimum value thus far. If -2 is the first element that I'm adding, then by definition it is the minimum value. So this is going to be my number x, and the second position is going to be the minimum so far. It'll be a -2. I'm now going to add the 0 in. When I add the 0 in, I'll add it as a nested array with the 0. And what's the minimum number so far? To answer that, I asked myself, well, what was the previous minimum number? And let's compare it to the number I just got. I just got a 0, right? I just got a 0. The previous minimum, which references the cell before us and its second entry, or at index 1, is -2. The smaller of the two will go right here. -2, the previous minimum, it will not change because by definition, everything here and before it, that minimum value is invariant. For all the elements that have happened up to then, whatever the minimum value was there, it will remain. To take it a step further, if we were to add the -3 now, not only would I add the -3, I would also say, okay, -3 is smaller than the previous min, so the new minimum is -3. If I go to the 4, I add the 4, I compare it to the previous minimum. The previous minimum was still smaller. We keep the -3 as it is, and so on and so forth. What happens now when I pop this off? Or if I want to run my getMin function. If I want to run my getMin function, what I've got to do is to check the final element's second entry. So I do that and I realize -3 has been the smallest element so far. Why is this handy? This is handy because if I pop this off now, this is now my final element. At this point, the fact that -3 was the smallest value, from this point and onwards. -3 was the smallest value from this point and onwards. -3 is still going to be the smallest value up to that point. Similarly, up to and including here, -2 is the minimum value. Whatever happens here, I know for a fact that in this chunk of array right here, -2 is the smallest value because I've been tracking it as I was going every single time. And the code to write this, guys, I genuinely think it's like 6 lines of code or something. The solution is very, how do I put it? It's a simple solution, but it's not an easy one, okay? I think this is far from an easy question, and if you're able to get to the point where you can piece together and understand here, you know, the logic to put the ability to put the logic together in terms of figuring out how to store the fact of what's kind of my trailing minimum as I go every step along the way, then you can really knock this out of the park. So I hope that explanation made sense. I'm going to jump into the code now, and as always, let me know in the comments down below if you've got any questions on the solution or the logic of it. So first thing we need to do with, as with any object-oriented design question, we've got to initialize the actual structure. Since all we're going to need is one array, I'll just call it self.stack and set it equal to an empty array. First, we want to implement this push method, and what we said is we want to do the following. We want to check whether or not the array is empty, and if so, we'll have 2 different actions. So we will say if not self.stack. So if it's empty, what we're going to want to do is to say self.stack.append, and what we're going to append is that nested array. And that will strictly just be the number and then the number itself, which is our minimum so far. Otherwise, what we want to do is we want to take the stack and append first off our number as it is, and then we want to take the minimum of the number in the previous entry's minimum. So right here, when we're adding it on, maybe I should have scribbled this out so neatly, but this number right here, this second one, if this is index I, then this number is strictly going to be the minimum, and this is, we'll call this x. This will be the minimum between x and, I'll call it stack at -1, so the previous element we had, so it'll be kind of I minus 1, but in this case, since we're always pushing to the end, it'll always be the current last element. And we are looking at its second entry, the entry in index 1. So this is the logic on how exactly we're going to go about picking the minimum of the two, the historical minimum, or the minimum we've had so far, and our current number right now. So what I'll do is take the minimum between x, like I said, and self.stack at -1, which I'm realizing here I took up a lot of space, -1, and we're looking at the second entry, or the entry at index 1. Okay, so we're just getting the minimum between those two, and this second item will always by default then keep track of what the minimum value has been. Pop is easy, okay, so that's kind of the hardest one in my opinion. Pop is pretty trivial because and we're not returning anything here either. All we need to do is say self.stack.top, all right? Top is simply going to return the top element in the stack. So we're going to return self.stack, and we're going to reference -1, and since they want us to return the integer, I'm specifically going to reference that first element, or the 0th element that sits right here in at that index 0 position within that nested list we're making. Right, so just really what we're doing is what our final solution will look like is, or not even final solution, but the stacks will all look like this, where we're going to have sum number A and then the minimum so far, B, the minimum so far, C, the minimum so far, so on and so forth. Now, when we actually want to get the minimum, this now becomes trivial because of how we've set this up. To get the minimum, all we've got to do is return self.stack at the final element we've got, and we want to return its second element, or the one in index 1. The position at index 0 is the number itself. The position of the value at index 1 is the value of the minimum number so far. And quite frankly, that's it. That's all we've got to do. Like I said, the solution is pretty trivial, and I'm just running through it super quickly to make sure I didn't make any dumb mistakes. And there we go. And that's all there is to it. So I really hope you guys learned something here. I thought this trick was wicked cool when I found out about it. And so I wanted to share. This one, some way, shape, or form, come up in the future for you, I'm sure. I really hope it clarifies the problem, and I hope, like I said, that you really learned something out of this problem. So, any questions, anything you want me to clarify or to answer, drop it in the comments down below. Like, comment, subscribe, yada yada. I don't need to tell you guys what to do, but I would appreciate it. I really would. And yeah, apart from that, I guess I'll see you guys next time. Peace.